readability or the DR side of things. So geo-replication, it creates readable replicas of your database in the same or different data center. The way it helps is also from a user perspective. If there are users distributed across geos and they need a local copy to access and have faster response times, it definitely helps you there as well. And you can manually fail over to readable replicas, and failover groups allows an application to recover. It's like an auto recovery for an application in case of a data center outage. Scale by easily adding more resources without long provisioning times, right? So that is one of the factors in a cloud environment, that the scalability is not constrained by the times. You can always upgrade or adjust your CPU or memory or storage without waiting too long. And then the advanced security features, we've all heard about how Microsoft is investing so much in Defender and Sentinel and the entire security landscape. So some of those advanced security features like threat detection and vulnerabilities, they're all pre-integrated into the service in the PaaS space, where data, and it enables you to secure your data. Uh, of course, one of the major uh, time that a lot of database teams spend on is performance tuning. Anytime the application is responding slow, the first thing everybody points to is, hey, it's the DBA's fault. So automatic tuning, it kind of analyzes your workload and provides you with recommendations that can optimize performance of your applications, mainly by adding indexes or removing unused indexes, and automatically fixing the query plan issues. And these are three of the major areas. If you're familiar with the time being spent by the DBA teams while doing performance tuning, a lot of these reindexing, and there are manual jobs that need to be created to rebuild the indexes. All that stuff is taken care of as a service. Built-in monitoring is another capability that enables you to get the insights into performance of your databases and workload. And it's not just about raising the alerts, but the intelligence which is built in kind of identifies the potential issues in your workload and provides you with recommendations that can help you fix the problems. Now, one additional difference that is significant between IaaS and PaaS is the idea of versionless SQL. So like in IaaS, where you are controlling the SQL version and you are installing and managing your SQL instance, the PaaS version uh, is not really tied to a specific SQL build number, right? The main branch of SQL Server engine code, it base powers the SQL 29 or 22, Azure SQL database, as well as the SQL MI. Uh, so SQL Server versions come out every few years, but PaaS services allow Microsoft to constantly update the SQL without going with major upgrade or downtimes. Essentially, what it works internally is how the agile and DevOps model is used for creating the version control, and you don't really have to worry about what's the at version of MySQL Server. So it allows for worry-free patching for both underlying OS and SQL Server, and for Microsoft to give you the latest bits, taking the responsibility also not to break you, right? So that's the another key difference between IaaS versus PaaS. So it takes away all the overhead from a PaaS perspective. Now, let's talk about certain use cases or why we would use SQL Server on Azure VMs. So SQL Server on Azure VMs, like it's the IaaS offering. What it is best for, it's for migrating the applications that require the OS level access. Now, when we are looking at a transformation project, especially from a database workload perspective, a lot of these decisions get made based on the kind of application that is running. Uh, so a common scenario from a customer challenge perspective can be, I want to migrate to the cloud as fast as possible, but maintain the operating system control and complete SQL Server functionality. In such a scenario, Of course, the challenges they are facing is that contract on my hardware is expiring. I have instances of SQL 2008 and 2000 R2, which are obviously legacy. I want to migrate to the cloud as fast as possible. I use third-party software that needs OS level access. I have dependencies on certain services like SQL Server reporting services, and I want to extend our on-prem apps to Azure. Uh, and then, of course, some of the other requirements can be about unlimited number of databases, because with PaaS, especially with the full Azure SQL model, you get one database per service or per instance that you provision. So if you want unlimited number of databases within and you want the OS level application control, then then SQL Server on Azure VMs becomes your automatic choice. Uh, so with SQL Server Azure VMs, you get access to file stream, DTC, simple recovery model, uh, and free extended security updates for SQL Server 2008 or R2. So these are some of the instance level features that we were referring to in the previous slide. Uh, but by just considering SQL Server on Azure VMs, uh, overall, we have seen that there's 435% overall return on the Azure IaaS investment over 5 years. And this is not something that I am saying. This is available on a Forrester consulting report. And from a performance benefit perspective, there's up to 3.4 times faster and 87% cheaper to run SQL on Azure. Now, some of the other advantages that you get from a security standpoint is that Azure Key Vault integration is already available even with SQL Server on Azure VMs. Uh, so these are some of the key features and differentiators on the slide. Essentially, from an accelerated performance perspective, you have Azure Blob caching, and then automated backups and security updates are also part of the service. Now, the key question here that you need to answer before making this choice is, does your application require custom VM or SQL configuration? The DB version choice, the feature compatibility with SQL Box, and app portability. So as long as the application requires, because there are certain applications which do memory management and integrate with the OS memory management module to ensure that there is in-memory transaction handling. In such scenario, you would prefer to go with SQL Server or Azure VMs. Uh, so uh, one of the major case studies that we talk about from a SQL Server on Azure VM perspective is Allscripts. Allscripts, as we all know, is a healthcare software manufacturer, and they saved a lot of costs while reusing licenses, and they moved around 600 on-prem VMs to Azure. SQL Server, a bit more about the SQL Server on Azure virtual machines. It's simply a SQL Server running on a virtual machine in Azure. Uh, and you choose the Azure VM, the configuration that you need. It is like configuring a physical or matching what you have running on-prem with as is in Azure VM. Uh, so there are multiple deployment choices from a marketplace pre-installed SQL Server on Windows or Linux, or you can install your own SQL Server. A lot of customers may have their own image in terms of a gold image that is security compliant from their security team. So in that case, they can install that image as well. So the lift and shift, as we call it, it's pretty straightforward from an Azure Migrate or Azure Site Recovery perspective. So the moving of your SQL workload to Azure SQL or SQL Server on Azure VM is pretty straightforward from that perspective. So SQL Server on Azure VM, it is like we said, it's considered IaaS. So you are responsible for updating and patching the OS, the SQL Server, apart from the SQL security patches. Security patches get installed as part of the service, but you have access to the full capabilities of SQL Server. Uh, The other thing that I really want to highlight here is the SQL IS, SQL Server IS agent extension. So you do get the benefit of availing this extension for licensing flexibility and to enable automatic backups and updates. So rather than going and configuring the SQL agent jobs, there is this extension available within Azure. You register your instance with the agent extension, and a lot of those job automations features you can avail. So consider the memory or storage optimized virtual machine sizes. Usually, when we are helping you scope a solution, we look at the existing configuration of the SQL servers, and then either Roshan or I will help you find the right virtual machine size as well as the storage configuration for this database instance. Uh, Now, another advantage of SQL Server on VM is size and storage performance. Like we said, you can easily scale up or scale down, and you can avail a lot of those cloud elasticity features available in Azure. Uh, it also takes the advantage of automated backups and backups to Azure Blob Storage, which makes it very easy and cheap. And then even from trying to run a hybrid environment, the Azure Virtual Network that can be integrated to your on-prem environment, and you can have a seamless uh, hybrid environment. So with SQL Server on Azure VM, you also get always on availability group. If you are familiar, so always on was introduced in with SQL 2005, and since then this the feature has been evolving and becoming more and more uh, enhanced. So that feature is something that you can always use, and you configure your SQL Server on Azure VM to act as a witness. And then, okay, so the networking, security, and the high availability features we talked about. Uh, the next step from an IaaS to a PaaS comparison perspective is the Azure SQL Managed Instance. Now, SQL MI, as we call it, is a PaaS deployment option for Azure SQL. It gives you an evergreen instance of SQL Server. That's precisely what it is. So most of the features available in SQL Server box products are available in SQL MI. This option is ideal for customers who want to leverage instance scope features. When we say instance scope, something like DTC, CLR, SQL Server Agent, or the service broker. So these are certain instance level features that are available in SQL MI. However, like I said earlier, the level of access to the OS is not given in a PaaS service. So, uh, database mail, linked servers, distributed transactions, or machine learning services, that's all integrated with SQL MI. Uh, and you don't really have to re-architect the application. Uh, while SQL MI allows customers to access the instance scope features, it doesn't. You don't have to worry about or uh, sorry, I lost the train. Yeah, you don't have to worry about the OS or the infrastructure underneath, and you don't get access either. So, uh, I mean, essentially. What usually at this point a lot of people are questioning what's the real difference, why is it called a managed instance. So essentially instance is the keyword here. If you know, traditionally SQL has always been an instance or instance and database one to many architecture. So with managed instance, you get an equivalent to a database engine instance of SQL Server, which is as good as a SQL Server instance with multiple database. Uh, so the term database engine instance is important because other instance types for SQL Server are things like SQL Server analysis services or and that's not something that is part of MI. So it's called managed because it is a PaaS version of database engine where we manage several things, including install of SQL Server, scaling, and high availability. So while on the SQL Server on Azure VM, you have to manage all this based on what your requirement is. With SQL MI, you get these pre-baked into the service. When I say these, the features like scaling and high availability. So that's where SQL MI kind of fits in. The key factor here is that you don't get access to the OS or the underlying infrastructure. So again, key features, single instance or instance pool, SQL Server surface area, native virtual network support, so that you can set up your hybrid environment, uh, and access to instance scope features like SQL Server agent, database mail, service broker, CLR. Uh, so with MI, you get near zero time downtime migration using log shipping. So if you're using MI and you want to migrate your on-prem environment, you all you need to do is provision a SQL MI instance and set up log shipping so that your databases get replicated over time. Fully managed business continuity with failover groups. Uh, and the projected return on investment of 212% over 3 years. That's what we have. Uh, Forrester has kind of analyzed over a period of time, and those studies are available online. So essentially, what happens, what MI gives you is combine the best of SQL Server with the benefits of a managed service. So it takes away a lot of overhead uh, from an OS and SQL management perspective while giving you full benefit of a SQL instance. So one of the case studies here is Komatsu, which they migrated 1.5 terabytes of data thanks to complete compatibility of SQL Server, and they achieved 49% cost reduction and around 25 to 30% performance gains. All right. So the highest level or the in the past, the next service is the Azure SQL Database. It is mainly built for modern cloud apps. So a lot of customers in the industry, they are kind of getting rid of their legacy applications. They don't want to use those older systems anymore, and they want to build something which is cloud native. In such scenario, the SQL database it becomes the obvious choice. So if it gives you the highest uptime and predictable uh, performance. Now, from an SLA perspective, Azure SQL Database, out of all the options, has the highest availability of up to 5 nines, along with other intelligent capabilities related to monitoring and performance. Mainly because Microsoft is essentially managing the entire instance. So this deployment option allows you to just get a database and start developing applications. The- So Azure SQL Database is the only deployment option that currently supports scenarios related to unlimited database storage, what we call hyperscale, and auto scaling for unpredictable workloads, which is serverless. So essentially, if you don't know what the application workload consumption will look like, and you're building that application as a cloud native application, then Azure SQL Database becomes the obvious choice. It gives you serverless has many advantages, especially from a cost saving and efficiency perspective. You're not paying for the service when it is not running. It provisions when the application requests. So you get best for best compatibility with your modern cloud applications, and unlike other editions of SQL Server, you do not need to provision any hardware or install any patch on SQL Server. Microsoft maintains the platform for you. All you have to do is set up a subscription, which you can always do through our cloud marketplace. Once the subscription is complete, the you can provision the service and start using SQL Azure database. You also don't need to architect a database installation for scalability, high availability, or DR, as these features are provided automatically by the service. Any application that uses SQL Azure it must have internet access in order to connect to the database. That's kind of given for any API driven development that you're doing within uh, a cloud platform. So ideally, applications that use SQL Azure Database are built for and deployed to the Azure platform. This provides the highest performance and reliability for database connections because all of the communication between app tier and the data tier, they all happen within Microsoft data centers using private high-speed networks. So there is no way. So from any cloud platform perspective, the internal network is not something that any of the external pipes can beat, and that is where these private high speed networks uh, add a lot more value from a cloud native and within the cross service communication. So you can configure SQL Azure to support connections from applications running on-prem, but quality of the connection will be limited to the bandwidth and reliability of your internet connection. So the moment we go outside, that's the limiting factor that we all know uh, that we have. Of course, there are additional solutions like deploying an edge device or a SD-WAN solution or a WAN accelerator to, of course, aggregate the bandwidth. That's something that we can always work out as a part of the solution when the opportunity arises. And that's where Ingram adds a lot of value because we can provide you with the end-to-end solution rather than just looking at providing you with pricing. So if you know how to develop applications with SQL Server or .NET or .NET Framework, then you already have many of the skills required to build cloud applications on Azure. Uh, and that's something that you can always explore, and SQL database, Azure SQL becomes the obvious choice for some of these applications. From a case study or a customer standpoint, AccuWeather is one of the leading examples. They use SQL database to provide automated, scalable weather prediction service. So we are not just talking about the scalability and high performance of the database, but based on you while using Azure SQL, they have realized the benefit of running that service as a cloud native service. Uh, all right, time for a knowledge check. So, Roshan, I would request you to please set up the poll so everybody can respond, and hopefully everybody was listening and I was making sense.
Just to confirm, is everybody able to see the poll in the chat? That it's in the chat, so please go to your chat, click on Start Quiz, and you should be able to respond to the poll. Again, to all the attendees, to respond to the poll, please go to your chat. You will see an icon saying Start Quiz. If you click on it, you'll see a pop-up where you can see the question and answer and a way to respond. Thank you.
All right, hopefully everybody has answered. If you're having trouble accessing the poll, just message us in the chat and we can figure it out. It's there in the chat window, anyways. Uh,
Let me push the second poll as well, since there are two questions here. The second one as well. So again, ladies and gentlemen, it's the same process. If you go to your chat, you will see an option saying Start Quiz. And if you click on the second one, it should work.
All right, so the two questions in the poll, of course, since we have been talking about what option is right for you, so the scenarios kind of explain whether you need OS access or not, and whether you need access to the instance scope features like SQL Server or CLR or Service Broker. So uh, all we need to do is choose the right option, because this helps. This is what Roshan and I do with you while asking these questions. So some of these questions will be helpful in understanding the scope or choosing the right service for your customers. All right. So I hope the time was enough. So let's move on to the answers and see where we are. Okay, so the first question, migrating to the cloud, but you leverage a third-party application which requires access to the operating system. So in such a scenario, SQL Server on Azure Virtual Machine is the obvious choice. The second question is more about the instance scope features where you want service broker capabilities and CLR. Then SQL Managed Instance is your a better choice, because you don't want the overhead uh, with respect to uh, managing the SQL Server. Okay, so now let's focus a little more on uh, you know the PaaS solutions, and especially when it comes to choosing between SQL MI or Azure SQL Database. So for you have multiple instances, so additional options for if you have multiple instances or databases, then these options are referred to as pools. Now, using pools can help at a high level because they allow you to share resources between multiple instances or databases and cost optimize. Uh, so Azure SQL Instance Pools, like I said, so essentially what you're doing, you're hosting multiple Azure SQL MIs and share resources. Uh, Again, when we say share resources, it is within your environment and within the VNet that or the subscription that you have set up. Uh, but if you have multiple MIs for different applications, then of course you can share the resources among the instances. So you can pre-provision how it works. You can pre-provision the compute resources, which reduce the overall deployment time and thus make the migrations easier. You can also host smaller. So sometimes, the traditional workloads have just two CPU because it has only one database or just an embedded database or SQL Express database. And some of these smaller ones don't need big Azure SQL database SQL MI configurations. In such a scenario, you can provision the compute and share or host smaller SQL MIs as an instance pool than just a single Azure SQL MI. Now, from a Azure SQL DB perspective, it also the we also get elastic pools. Now, elastic pools, they host many databases that may be multi-tenanted. This is ideal for SaaS applications, or if you're kind of building a SaaS application and ready to provide that as a service, then you can manage and monitor performance in a simplified way for many databases. From a service tier perspective, both for SQL DB and MI, uh, you have your general purpose and business critical service tiers, as well as hyperscale. Now, once we figure out or once we decide the deployment option that's best, uh, the purchasing model or the service tier uh, and the hardware is the next thing to determine. And so service tier, the next what is service tier? But in general, the general purpose is a good starting point. It is usually good for most of the business workloads, uh, and it offers budget-oriented, balanced, and scalable compute and storage options. From a business critical perspective, so the next level of service tier, uh, it is mainly for highly critical business applications with low latency response requirements. Uh, so business critical also offers highest resilience in terms of the failures by using several isolated replicas. So this is the only tier that can leverage in-memory OLTP. Um, and that's another key database feature, especially from an application standpoint, that a lot of applications, at least the high performing ones and something that is not really a legacy one, they have this capability of doing in-memory online transaction processing. And if you have such a application that requires this capability as well as the response times, then business critical tier becomes the obvious choice. Hyperscale. Now, most business workloads with highly scalable storage, which is almost 100 TB plus, and the read scale requirements. So, from a performance and cost perspective, hyperscale falls somewhere between general purpose and business critical. And currently, it is available only for single databases and not for MIs or pools. So if you choose general purpose within Azure SQL DB and the vCore based model, you have an additional decision to make. Now, what is vCore model? So when you are provisioning the SQL on uh, uh, on Azure, there are two models. One is vCore versus the other is database transaction unit. Now, DTU is something that again it is a kind of a unit defined which is based on a combination of CPU memory and the storage requirements or the transaction requirements. However, it is still evolving and sometimes it is difficult to understand, and it becomes a little a good starting point for comparing the on-prem environment and choosing the vCore based model, so that you have kind of a like to like, or you have a better understanding of what the workload performance is looking like. Uh, Now, with vCore based model, the additional decision has to be made in terms of the provision compute. Provision compute is meant for more regular usage patterns when we already know it's like a production workload with certain application traffic based on what we see in the on-prem environment. Uh, and then the other option is serverless compute. And serverless compute, like we talked, is meant for intermittent, unpredictable usage. So if we don't know what the database really does or what sort of application requirements will come into picture, then serverless is also another option, which can auto pause and resume the capabilities with a little bit of time delay that you set, meaning when your database is paused, you only pay for the storage. So that's another aspect to consider from a serverless perspective, that while serverless reduces the cost, the storage cost is still consistent, but it still is a lot lesser than just going with a pre-provisioned compute, and if we don't know what the application usage will look like. What we'll do as part of this slide deck, there would be additional links in terms of serverless versus provision compute, and it'll give you a little more understanding. And if you have further questions, you can always reach out to us. Right. So purchasing models, again, coming back to the DTU versus vCore model, a little more on what uh, it means. First thing, the DTU model is not available for Azure SQL MI. The vCore model is usually recommended because it allows you to independently choose compute, store, and storage resources, while the DTU based model is a bundled measure of compute, storage, and IO, which means you know especially when customers are new to cloud, or they don't want a bill shock, or they want to understand what the cost exactly would look like, then vCore model becomes a little bit uh, more concrete rather than leaving it to the because DTU is again usage based, and then you will only get to know exact DTUs when after a month of consumption. So uh, which is why the vCore model is always a good starting point. And uh, along with the DTU or the vCore model. So the vCore model has another advantage where you can avail Azure hybrid benefit for SQL Server and also reserved capacity. Because vCore model lets you define how much of CPU and memory requirement you have, you can always go with Azure reservations and the hybrid benefit. Now, when Roshan and I are working with you, we always suggest availing the hybrid benefit wherever it makes sense, and for maximum cost efficiency. And reserved capacity is also part of the solution. And we give you a comparison of how the pricing difference works, and if there are any additional questions, we help you answer that. But the way hybrid model works, if you have an existing SQL license uh, that comes with software assurance, or if the license is expiring, then we can purchase core-based, term-based and core-based licenses from our marketplace as well, and apply those licenses. There are some calculations where sometimes it doesn't make sense when the machine is too small and the licensing cost from Microsoft is not very high. In such cases, we can ignore, but otherwise, we always bake it into the solution and explain the cost benefits as part of helping you scope out the opportunity. Uh, so in the VCO model, you pay for compute resources. So you define the number of vCores, the amount of memory, and the generation of hardware. So when we say generation of hardware, it's the virtual machine series. Now, the type and amount of data and log storage and the backup storage. So when we are going through that solutioning exercise, we also define whether we need read access geo-redundant or zone redundant or locally redundant storage for backups. So this is, kind of becomes a little more easier from a cost estimation perspective and realizing all the advanced cost benefits that Azure platform offers. So, uh, which is why we kind of prefer to start with vCode model. Now, the next is again a little bit more on Azure SQL Database serverless. So serverless, like we said, so there are certain of line of business applications or dev test databases or content management or e-commerce systems. They all are good candidates for using serverless features. Uh, Essentially the wherever we start talking about serverless, it's mainly from a usage pattern. If we are not If there's no predictable usage pattern, then serverless kind of makes sense and should be explored. It is also well suited for new applications with compute sizing uncertainty or workloads which require frequent rescaling in order to reduce costs. Uh, it also if we look at it from a user perspective, it also gives the flexibility or the peace of mind to the application team or the application developers that this serverless model will kind of support whatever requirement or user need comes up, even when we don't know how many users will be using the application at a given point of time. So serverless automatically scales compute for single databases based on workload demand and bills for compute used per second. In serverless, essentially the compute scaling within the configurable limits is managed by the service to continuously right size the resources. Again, it definitely comes into picture not from a initial migration perspective, but mainly when you are not sure of the usage pattern, or if there are dev test workloads that sometimes uh, we don't know when the dev or test workloads will be used, so or unpredictable workload needs. Just to reiterate, during the periods of inactivity, you only pay for storage. You don't pay for CPU or memory or any of that compute. Okay, now from a hardware uh, perspective, there are multiple options when we are looking at choosing the right hardware for or the right virtual machine series in terms of how the SQL is supported. So the default hardware generation usually is Gen 5 hardware, as you know, and we all know that Microsoft is constantly releasing and optimizing the virtual machine series and optimizing it for certain workloads, and especially from a economies of scale perspective, they also pass on and try and make it the new generation VM series as cheaper than the last one. So which is why we should always look at what's the latest generation going on. And Roshan and I do help you with that as part of the solution scope. So, for example, from a SQL perspective, we have FSV2 series, which is the compute optimized or the memory optimized, or even the DC series, which is the confidential computing hardware option. Uh, and all these are available to SQL database, and you can we can there is a link in the slide deck that you will get, which gives you the latest hardware generations and their availability. Now, if we choose general purpose for Azure SQL DB and we want to go to the serverless compute tier, the Gen 5 is currently the only option, and it can scale up to 40 V cores. Excuse me. Sorry. Okay, time for another knowledge check. So Roshan, please do the honors.
It should be in the chat now. I would appreciate if everybody can go to the chat and start the question 3 quiz.
Two simple questions, essentially. The first question is all about not requiring instant scope features. So, and then database is already 62 terabytes. So, and then continue to grow.
Okay, once people have participated in question 3, I'm pushing out question 4 as well. So you can take them up one after the other. Thank you.
So the second question is focused on the serverless, and I think I went a little overboard in explaining the serverless concept, but from a cost perspective, uh, it's a good question to come back to whenever we are talking serverless. It's good to have these polls in between. Give me a chance to sip a cup of coffee. But yeah, I hope everybody has answered. So I think we'll move to the answers. So from an Azure SQL database perspective, like we said, so Azure SQL database, single database is the option here, uh, especially because of the database size from a 62 terabyte perspective. Question was a little confusing. Both C and D were the right options, but the database size is the key differentiating factor there. Elastic Pool is mainly for shared or smaller instances. Going to the next question, like we talked, for serverless, you only pay once it is paused, you are only paying for storage and not really for any compute costs. Hope this was clear. Now, from an interface, so what do you do? From a when you need to provision the service. This is a cool slide because it makes my job a little easier. It has a good simulation in terms of the options that you get when you search for SQL. So The first interface or where the simulation is running is the Azure portal. So Azure portal, I'm sure we are all familiar. It's a well integrated for Azure SQL resources. So you can provision either the virtual machines or the MI or the Azure SQL database. Uh, the concept of Azure SQL is baked into the portal experience for both managing resources as well as deploying the SQL options. Now, from a day-to-day management perspective, any DBA team will already be familiar, but Management Studio is the most famous and the most popular tool for SQL Server in the world. Uh, so SSMS is integrated to understand how to visualize and work with Azure SQL. So the teams or the customers don't have to worry about how they will manage or will they be learning or managing it through only Azure portal, because the database management happens through Management Studio. Uh, uh, and it is integrated with Azure SQL, including the SQL Server and virtual machines. So whether you choose the IaaS option or any of the PaaS options, the Management Studio works the same. Another tool uh, that we have is the Azure Data Studio. It's a new open source cross-platform tool to query and work with various Azure data sources. And these data sources are not limited to, but include SQL Server and Azure SQL. Now, at ADS, it supports a powerful concept called notebooks, which come in very handy and make the querying quite easy. Now, apart from that, of course, being a cloud service, Azure SQL services are offer APIs, and the API is based on SQL Server Engine. It supports the T-SQL language as well as the TDS protocol. So all the drivers that normally work with your on-prem SQL Server, they all work with Azure SQL as well. Now, in addition, Azure SQL also supports REST APIs for management of MIs and databases. So the REST APIs will not be applicable to the IS side of things because that's your traditional SQL Server running on a VM. Uh, the next tool or another tool is, of course, the CLI or the SQL CMD and the BCP, which are traditional command line tools that have been there in the SQL ecosystem, and they all work with Azure SQL as well. Now, with Azure SQL, you also get the additional, or you get to also use the CLI tools available in the Azure ecosystem, mainly from an AZ or Azure CLI, as well as the PowerShell CMDlets. Uh, so all of these are supported not just on the Windows, but also on Mac OS and Linux clients. And we all know SQL Server on Linux is also in the market. So there is nothing like Microsoft doesn't work on the Linux systems, right? So we don't have to worry about that too. Now, okay, so that brings us to our summary. So, like we said, Azure SQL has evolved into the world's database. It includes IaaS and PaaS services. So, virtual machine with SQL Server on it, or whether it's the PaaS side of things with Azure SQL MI or Azure SQL Database. SQL Server on Azure Virtual Machines is best for 100% lift and shift, or the as-is provisioning of SQL environment on in Azure. The SQL MI, it's the database engine with the instant scope features, plus the power of platform as a service. While the Azure SQL Database is best for modern cloud apps, providing you with most PaaS capabilities. This brings us to some of the important links, and the just a reminder that it's lunchtime, so uh, we will share the slide deck, and go have sushi or sandwich or whatever you prefer. But we'll share the slide deck as a and with these additional links, and you can always come back to us for any questions or queries that you may have. So thanks so much for joining, and we appreciate your time today. Uh, like I mentioned at the start, this is a series of webinars. So today was the first session, and we'll have the next session on 8th of June. Roshan, is that? I think it's 8th of June, but you'll all be getting invites for the same too.
Yes, so the next session is on 8th of June, where we'll be talking about how you can migrate your on-prem SQL Server into one of these options which Engage discussed. So I'd appreciate again if you can join the session and give us your feedback. If you have any questions from today's session, you can always drop us an email and we'll be happy to get back to you. That's it from our end. Thank you very much, ladies and gentlemen, for joining the call. Hope it was helpful. And yeah, have a great day ahead. Thank you.
Thank you everyone. Cheers.